Hello students, in this video we are going to clear our concepts on centripetal acceleration, which is there in uniform circular motion, a topic from the chapter motion in a plane. Now with the help of this numericals we will see that in how many different ways we can solve the tangential acceleration, find out tangential acceleration and centripetal acceleration based on the conditions given in the numericals. So let's begin. Now as you can see in the first problem, it is given that a particle is moving in a circle of radius 3 meter with an angular velocity 2 radian per second in the clockwise direction. That is shown in the diagram alongside. So we need to find the acceleration of the particle at the point Q, and the options given, as you can see, the 4 options are there. So the given information r equals to 3 meter, angular velocity 2 radian per second. We know the relation between the velocity and the angular velocity, which is v equals to r omega. So substituting the values of r and omega, we get the velocity to be the constant speed with which the body is moving along the circular path, is 6 meter per second. Now the magnitude of the centripetal acceleration is given by v square by r. V square by r. So let's put the values in place of v and r, which is (6 into 6 by 3). So that gives us 12 meter per second. So the centripetal acceleration at the point Q in the vector form is minus 12 cos 60 I cap minus 12 sin 60 j cap. Now why I am writing this? Please refer to the figure. Here we have already calculated the magnitude of the centripetal acceleration directed towards the center O, 12 meter per second square per second square. Now this acceleration is resolved into 2 components. One component along the y direction, y axis, along the y axis, and another along the x axis. So the x axis component is AC cos 60 degree. Now we substitute the value of AC, which is 12, and cos 60's value is half. And why I have taken this minus? Because we can see from the figure the x component is towards the negative direction of x axis. That is why. Similarly, the y component, which is AC sin 60 degree, is also directed along the negative y direction. So here also we have to take for that the minus sign, and the values after substituting gives us minus 6 I cap minus 6 root 3 j cap meter per second square. So the correct option is the first option. Answer is option 1. Now coming to the second sum. Second sum, here a particle is moving along a circular path. Its initial position is at P and the final position is at Q. Now it is moving with a constant speed of 4 meters per second at P, as well as you can see at the point Q. At both these points the constant speed is 4 meters per second. Now here the velocity of the body at point P we can take as in the vector form 4j cap. As you can see, the body is moving along the positive y direction, so we have taken it 4j cap. The velocity of the body at the point Q, we can resolve the velocity. The net resultant velocity is directed in this direction, so it can be resolved into two perpendicular components, one along the negative side of x-axis and one along the positive direction of y-axis. So that is why for the x component I have given a minus sign 4 cos 30 degree, and for the y component 4 sin 30 degree j cap. Now substituting values of cos 30 and sin 30, we get the velocity vector to be minus 2 root 3 I cap plus 2 j cap. Now we need to find, for finding the average acceleration, we need to find the change in velocity. So change will be the final velocity at point Q minus the initial velocity at point P. That is why I have subtracted the two velocities at Q and P, which gave us the magnitude 4 meters per second. Now to calculate delta t, that is the time interval during which the particle moves from points P to Q, for that the length of the arc has to be calculated. So we can see the sectorial angle is 60 degree by the whole angle, that is the angle about the center is 360 degree multiplied by the circumference of the circular path, wherein substituting all the values we get the value 44 by 21. Now speed given is 4 meters per second. So how to calculate time? The length of the path traversed between P and Q divided by the speed. So we did that 44 by 21 divided by 4, and that gives us the time, which is 11 by 21 seconds. Now to get average acceleration, we know it should be delta V by delta t. So now putting the values of delta V, which is 4, and delta t 11 by 21, we get 84 by 11 meter per second square. So in this case, the first option is the solution of this question. Now in an alternative way we can calculate the change in velocity. So here change in velocity delta V is given by root over of the two vectors which I have drawn here beside. So V1 you can see directed along say y axis, and V2 is making an angle 60 with V1. Now if we take the negative of, that is minus of vector v1, we can write it as minus v1, which will be directed opposite to v1. Now the angle between negative v1 and v2 becomes 180 minus 60, that is pi minus 60 is 120 degree. So we here put the values v1 and v2, since the speed is constant, so v1 v2 will be equal to v. So substituted the values of v1 and v2 as v and v. Here also the same thing is done, and cos 60 lies here 180 minus 60, so the cosine of the angle is in the second quadrant, and we know that cos is negative in the second quadrant, that is why this minus sign comes. Then putting the value of cos 60, we get the change to be v. Now we can substitute this delta v as v, and delta t we have already calculated 11 by 21. Putting that, we get the same answer. So for finding the change in velocity from one point to another point on a circular path, the formula is delta v equals to 2v sine theta by 2. So if you remember this formula, we can easily calculate the change in velocity and thus find the average acceleration. Now the next sum, in the next sum you can see a particle moving along a circular path of radius 1 centimeter at a speed given by this equation. So here we can see that the velocity is a function of time and it varies with time, and here the v's unit is centimeter per second and t is in seconds. So we need to find the total acceleration. So as t changes, v changes. So we have a tangential acceleration, and at a given instant the body has a particular speed. So using that speed we can calculate the centripetal acceleration. So first we are calculating the centripetal acceleration. So here you can see I have calculated the value of the speed, that is the magnitude of the velocity, using the given relation v equals to 2t. In place of t, as they have said for t equals to 1 second, so I have put 1, so 2 centimeter per second, and putting this v value in AC's equation, we get the centripetal acceleration to be 4 centimeter per second square. Now the tangential acceleration at is given by dv by dt, d by dt of 2t equals to 2 centimeter per second square. So total acceleration is the square root of the sum of the squares of the two accelerations, which is given as root 20 by putting the values, and thus the final answer is 4.5 centimeter per second square. So here the option 1 is the correct answer. Now the next sum, here a ball is moving in a circular path of radius 5 meters. So the radius of the circular path is given. Tangential acceleration is also given 10 meter per second square, and the resultant of tangential and centripetal acceleration, which is the net acceleration, makes an angle of 30 with the centripetal acceleration. So we have to find the instantaneous speed utilizing this information. So a net is equal to a let us suppose that. And AC, now this A net can be resolved into two components. The vertical component is the tangential acceleration and the horizontal component is the centripetal acceleration. So we can write AC equals to A cos 30 degree and AT equals to A sin 30 degree. A sin 30 degree is given as 10. Substituting sin 30's value, we get A equals to 20 meter per second square. Now, the centripetal acceleration is given by A cos 30 degree. Again, substituting values of cos 30, we get it to be 10 root 3 meter per second square. Now, both the tangential and centripetal accelerations are known to us. So, from the centripetal acceleration equation, that is AC equals to V square by R, we can calculate V square. So, substituting the values of AC and R, we get V square to be 86.6. And then square rooting 86.6, it comes approximately equal to 9.3 meter per second. So option 2 is the correct answer. Next, sum number 5. Here the speed of the particle again varies with time, which is given by the equation V equals to 2t square. And we are asked to find the acceleration of the particle at t equals to 1 second. So, as we have done in a similar sum earlier, we will find both tangential acceleration by differentiating the velocity with respect to time and then substituting values of t. We get it as 4 meter per second square, and the centripetal acceleration using the formula V square by R, we get 4 meter per second square. So both the accelerations are 4 meter per second square each, and so the net acceleration will be the sum of the squares and of the two accelerations square rooted. It gives us 4 root 2 meter per second square. So option 2 is the correct answer. Now the next sum, again a body is moving along a circular path of radius 16 meter. Now here it completes one revolution in 8 seconds. That is, the time period is given. Time period is 8 seconds. Now angular velocity omega is equal to 2 pi by the time period. So putting the value of time period, we get the value of omega to be 5 pi by 4 radian per second. Then as R and omega are known to us, we can easily find out the value of the speed. V is 4 pi meter per second. From there, the centripetal acceleration V square by R is coming after substituting all the values of V and R, 484 by 49. So option 1 is the correct answer. Now for the seventh sum, here the angular velocity is increasing from 100 revolution per minute to 400 revolution per minute in 5 minutes. So we know the relationship between angular velocity and frequency f. Now in 60 seconds, 1 minute equal to 60 seconds, the particle revolves 100 times. So in 1 second, how many times the particle will revolve? it is given by 100 by 60, so it is 5 by 3 revolutions per second. So that is the initial frequency. Therefore, initial omega will be 2 pi multiplied 5 by 3, which gives us 10 pi by 3 radian per second. Now the final frequency is 400 by 60. So that gives us 20 by 3 revolutions per second. So final omega is 2 pi multiplied the final frequency, which is 40 pi by 3 radian per second. So initial V is obtained by multiplying the radius of the path, circular path, multiplied the initial omega, that is 5 pi by 3 meter per second, and final is 20 pi by 3 meter per second. So delta V will be final V minus initial V. After substituting all the values we get, and delta T is given as 5 minutes. So 5 minutes when converted to seconds gives us 300. 5 pi by 300, that comes equal to pi by 60 meter per second square. So option 4 is the correct option. Now the next sum, it is given that the car is traveling in a circular path with a constant speed of 30 meter per second and the radius is given 500 meter. It is increasing its speed at the rate of 2 meter per second square. Now when the speed's magnitude changes, that means it is the tangential acceleration value given to us. Now if we find the centripetal acceleration, then the resultant of the two accelerations will be the acceleration of the car at that instant. So AC is found by this formula V square by R. We substitute the values and get it to be 9 by 5 meter per second square, and tangential acceleration is 2 meter per second square, already given. So if we square and then add and then find the square root, it gives us 13 by 5, which is 2.7 meter per second square. That is option 3 is the correct answer. Now the ninth problem, here the particle is said to be moving at a constant speed in a circular trajectory. So it is for sure that there will be centripetal acceleration, and the trajectory center lies at the point O, which is the origin of an xy coordinate system. A point is given whose coordinates are 4 meter and 0 meter, and at that point the particle's velocity is minus 5 j cap meter per second. So for the minus sign we draw the tangent towards the negative direction of y-axis. Now for the acceleration magnitude, we substitute v equals to 5 in the equation v square by r is equals to, and get 25 by 4. The result is 6.25 meter per second square. So therefore in the vectorial form we can write it as negative of 6.2 I cap. This is why, because the centripetal acceleration is always directed towards the center. So if the acceleration is directed towards the center, that means it is directed towards the negative direction of x-axis. So therefore option 1 is the correct answer. And the 10th sum, which came in the year 2015 for JEE Mains examination, the particle is moving along a circular path with a constant speed of 10 meter per second. and it is asked to find the change in velocity of the particle when it moves through an angle of 60 degrees around the center of the circle. So as we discussed earlier, that change in velocity as a particle moves along a circular path from one point to another point can be given by the formula delta V equals to 2V sine theta by 2. Here theta is 60 degrees, so theta by 2 30 degrees. Substituting the values, we get it to be 10 meter per second. So therefore the fourth option is the correct answer. I hope you find these numericals helpful. If you like the video, do hit the like button. And that's all for today. Hope to meet you soon with another set of numericals from a different concept. Thank you.